Alright class, so we're going to continue going over how to figure out the unit circle more in terms of figuring out angles that are inside the unit circle given what I just taught you from the last time. Now we're going to learn about two specific right triangles today. We're going to learn about the 30, 60, 90 right triangle and the 45, 45, 90 right triangle. First we'll go over the 30, 60, 90. Alright, so the 30, 60, 90 is written obviously as this right here, this triangle here, where you have 60 at one angle, 30 at one angle, and 90. Now it may change, it could change at any different point. We'll go over examples later about that, okay, about depending on where your angle is looking at, alright, in terms of the point of view of which angle. Alright, but for the measurements of each side, alright, as you get here adjacent to 30, you're going to get the square root of 3, alright, and then opposite of 30, you're going to get the value of 1, okay, and then at the hypotenuse, you're going to get the value of 2. All right. Now, let's say if we ever wanted to solve something, and this is to help you specifically if you didn't memorize the unit circle that I gave you guys earlier. When we're solving for something, let's say if I gave you sine of 3. I'm sorry, not sine of 3. Sine of 30 degrees, right? If I wanted to find sine of 30 degrees, well, we know 30 degrees is here. Okay. Now, if I wanted to solve sine for 30, you have to remember these things. SOHCAHTOA. Right? SOHCAHTOA. Alright? And these things will help you as well, that mnemonic device. Okay? We're going to go back to that. As you can see, this whole thing was going to be able to help you. Also, another thing for you guys to remember is that sine is all your y values. And then cosine is your x values. Okay? And then therefore tangent equals all y values over x values. Okay, so if I wanted to solve for sine of 30 degrees, you want to look for first what does sine represent. Now, in terms of SOHCAHTOA, SOHCAHTOA is SOH, so therefore sine represents opposite over adjacent. Right, so you're gonna get opposite. I'm sorry, not opposite over adjacent. Opposite over hypotenuse. Apologize. Opposite over hypotenuse. All right. OH, opposite over hypotenuse. All right. So now you're just gonna look for the according to the angle of 30 degrees, that angle right here. Where's your opposite sign? Your opposite sign is here. 1. That is your opposite sign here. So you're gonna get sine of 30, right, equals 1 over. Now, where's our hypotenuse? Our hypotenuse is always gonna be this line here, which is your longest side, which is 2. Ends up being 2. All right. So therefore, sine of 30 equals 1/2. Now, if you were to plug that into your calculator as well, you would get the same exact answer. Obviously, they give you in a decimal form. In a decimal form, it would be 0.5. All right. Now, what if I wanted to solve for cosine? All right, cosine, say cosine of 30, right? Cosine of 30. All right, now cosine of 30, you have to remember it like this. Cosine of 30 is represented by what? Cosine is CAHTOA, right? The ka in SOHCAHTOA, right? So therefore, it's A over H, all right, which is adjacent over hypotenuse, right? So now you would plug in cosine of 30. Now, what is my adjacent value to 30? It's actually square root of 3. Okay, and then you would divide that by what is your hypotenuse? 2. All right, so this is your answer. All right, now if you were to actually look back, let me write back sine for you guys, so you guys to see sine of 30 would equal 1 over 2. Okay, now if you remember I told you how your sine values are y and your cosine values are the x values. Now, if you look at 30 degrees in your unit circle, you'll notice that the xy coordinate for 30 degrees is square root of 3 over 2, comma 1/2. All right, so it does make sense. Now let's try sine of 60. All right, just something simple. All right, sine of 60. All right, now sine of 60 degrees. Now we have to look at it this way. You have to look at it where 60, the point of view of where 60 is from. All right, now we're asking for sine of 60. So sine of 60, you're saying it's opposite over hypotenuse, right? So what's opposite of 60 at this point? Square root of 3. Okay, so you're gonna get sine of 60 equals the square root of 3 over, now hypotenuse is 2. Okay, square root of 3 over 2. Now let's try cosine of 60. Cosine of 60. All right, now cosine of 60 is the CAHTOA, which is adjacent over hypotenuse. Okay? All right. So now you're going to take what's adjacent to 60, 1 is adjacent to 60. All right, so now you're going to take cosine of 60 equals 1 over, now what is the hypotenuse? Is 2. All right, okay, so now your cosine value of 60 is 1 over 2, while your sine value of 60 degrees is square root of 3 over 2. So therefore, in the xy coordinate, if you look at the xy coordinate where you see 60 degrees, in your unit circle, you would see that it would be 1/2, comma, square root of 3 over 2. And that is your value, or your xy coordinate for 60 degrees in the unit circle. All right, now let's try to solve for your 45-45 right triangle. All right, now this is known as an isosceles right triangle. Isosceles, and I'll probably put it in the video, isosceles right triangle, which is 45, 90. All right, and the good thing is that in this side of it is both sides, they're equal. All right, so you have 45 and 45, so it doesn't matter what you put, where you put them, they're gonna get the same matching, sides. And you'll see when I give you the measurements here, that your adjacent side and your opposite side are always going to equal 1. All right, and therefore the hypotenuse actually equals the square root of 2. Right? So if I wanted to tell you what is to solve for sine of 45 degrees, all right, sine of 45 degrees, now we know that, remember we went back to SOHCAHTOA, as you can see right here. SOHCAHTOA is OH, right? So it's opposite over hypotenuse. Now doesn't matter where you look at this point, your opposite is 1 and your hypotenuse is square root of 2, right? So you're gonna get 1 square root of 2. Now remember what I told you before, guys. What's gonna happen here is that you're going to go ahead and you're going to simplify this function down, because you have to rationalize because of the square root of 2 in the denominator. So what you're gonna do here, you're gonna multiply square root of 2 up top, square root of 2 at the bottom. Okay, now you're going to get 1 times the square root of 2 is the square root of 2. All right, now square root of 2 times the square root of 2, right? These two here, they equal the square root of 4. Okay, they equal the square root of 4. The square root of 4 is 2. All right, that simplifies to the number 2. So therefore, sine of 45 degrees is square root of 2 over 2. Now if you look back at your unit circle again, and you look at the y value, because remember y value is represented by sine, that it's square root of 2 over 2. But if you notice that they're both actually equal to square root of 2 over 2. Your cosine and your sine value is square root of 2 over 2. But just in case, let me show you guys again. Cosine, all right, of 45 degrees. All right, now cosine of 45 degrees adjacent, okay, over hypotenuse. So adjacent over hypotenuse or adjacent over hypotenuse. I mean, it doesn't matter. Adjacent over hypotenuse, depends on where you're looking at it from. That's what you're going to get. So you're going to get 1 over square root of 2. Okay, but like I said, you have to rationalize here. So you multiply the square root of 2, which equals 1 technically, right? But you multiply it by this function here. All right, now you're going to get the square root of 2. Now remember, I told you square root of 2 times square root of 2 equal the square root of 4. Okay, square root of 4 just equals the value of 2. So therefore, cosine of 45 degrees equals square root of 2. So if you wanted to look at your xy value on the unit circle, you would see that it would look like this: square root of 2 over 2, comma, square root of 2 over 2. Okay, really easy. All right. Now, if you wanted to solve for tangent, remember I told you, I didn't go over this with the 30, 60, 90, but let me go ahead and do it with you guys here, solving for tangent of 45 degrees. All right. All right, so then if I take tangent of 45 degrees, okay, you notice that I told you it's every y over x value. Now you figured out that the cosine and the sine are the same thing when it comes to your 45. So all you're going to do is take the square root of 2 over 2 divided by the square root of 2 over 2. Now these two cancel. All right. All right. Now this is the long way. I mean, you can rationalize it. It's simply by common sense, but this is to show you actually how it works. Now the 2's cancel. Now you're only left with the square root of 2 over the square root of 2. Okay. Now, but like I said, you have to rationalize the bottom. So what you're going to do here is you're going to multiply by the square root of 2 over 2. Square root of 2 over the square root of 2. Sorry. So this becomes the square root of 4. This also becomes the square root of 4. Okay. So you're going to get the square root of 4 over the square root of 4. Okay. They both reduce down to 2 over 2, which reduces down to 1. So, okay. So tangent of 45 degrees should equal 1.
What's good? Yo, dog, not astronomy, eh? An astronomy attack.